Okay, hello, good morning, good afternoon, whichever time zone you are in. My name is Piotr Golkiewicz. I'm customer success consultant, subject matter expert for life science portfolio at Elsevier. And this meeting is one in the series, actually last in the series of 3 meetings supporting searching on Reaxys and sort of technical questions. And this meeting is devoted to query builder, how to ask complex questions in Reaxys. So it will be pretty technical and I would say a little bit more advanced level. So bear with me if you are new to Reaxys and you would like to get some basic information. You can watch some other webinars on how to search in a quick search or how to use the structure editor. You can also ask always a question, and here on the screen you see my email address. You can always write to me and ask if when you have any problems or questions regarding searching in Reaxys, or if you want maybe to organize a separate meeting, separate training for you and maybe group with your colleagues in your lab or department, it's always possible. So whenever you need any support, please let me know. I will be glad to help. Throughout this meeting, please use the chat option to ask questions. I already see people saying good morning, hello, hi, hello to everyone. This meeting is recorded, as I mentioned, so that we want to share it with other users of Reaxys, and we want to use this for later education as well. So we will also share the recording, link to the recording with you, as well as I will also share the link to the Researcher Academy, where you can download your certificate of participation in this training as well, if you wish, of course. So let me show you, as usual, a couple of introductory slides. I always do it because I notice I have new participants every time, and I'm not sure what level you are, and I'm not sure what you know about Reaxys. So I always repeat this. This is 5 minutes, which is always the same at each webinar. So if you already participated in the earlier seminar and you already know this, you have 5 minutes to go and grab a cup of coffee or a tea because maybe you already know this, but I really want to make sure everybody is aware of this. So let's start, and really a couple of slides, and then we go online and we practice Query Builder Advanced searching. And of course, please ask questions. Again, use the chat to ask questions. So again, a little bit of repetition, a little bit of reminding what Reaxys is. Many people think it's a organic reactions database, and it's not for a long time. It's the database that compiles information from many, many different sources. Of course, it started with Bastine, Gmelin, organic or inorganic chemistry databases, so that's the base. But since then, of course, a lot of new content is added since 2009 when Reaxys is launched, or even before when it was existing as Crossfire Ballstein. It was covering not only organic, inorganic chemistry, but also other areas of chemistry. Just to mention a couple of important additions, in 2017, we have added Reaxys medicinal chemistry, which is the bioactivity module, and we developed this since then. And this is a big part of Reaxys. So if you are in biochemistry, biological activity, biotechnology area, then this is the tool for you. This is a must-have. Now it's called Reaxys Targets and Bioactivities. In the meantime, we also added Reaxys commercial substances. It's already 5 years. We have more than 400 different suppliers of reagents, of chemicals, and you can check directly in Reaxys the availability, commercial availability of those. And especially if you are a synthetic chemist, definitely this gives you already an idea if your synthesis ends up with a starting material that is commercially available. You can check immediately if, where, and for how much, and what is the purity of those, etc. Since 2021, we are developing huge patent expansion project. We grew from 7 to 105 patent offices, 170 patent classes. Big effort to make sure that patent coverage is up to date, and it's really covering all meaningful resources. So that's very important. As I said, RMC, which is Reaxys Medicinal Chemistry, changed to Reaxys Targets and Bioactivities in 2022. Since then, it's also developed, new features added. And in 2021, we also added a new module called Predictive Retrosynthesis. We had a last webinar devoted to this, so you can watch the recording as well. Let me know if you don't have a link, I can send you the link as well. Predictive retrosynthesis, which is the artificial intelligence-based synthesis prediction tool. Now we use two engines. One is from Pending AI and one is from Ictos. So we have two engines. Both are very similar and offer similar possibilities. So Reaxys is developing. This is not all. We are now working on new developments like vector search, like adding new contents, new functionalities. So it's growing, and definitely this is not it. And I think artificial intelligence on top of vector search is the next step as well. The core philosophy of Reaxys, let me see if there is any questions. No, okay, people are saying hello, great. The core philosophy of Reaxys is to deliver the information as quick as possible. This is based on extracted information. So we want to save your time that you normally use for reading many different papers and patents, and searching for the information, extracting information, putting this into one Excel spreadsheet, for example, or any other place, and then analyzing. So we want to give you the data as quick as possible. And this might be a structure, reaction, physicochemical properties, bioactivity, whatever it is. We try to give you access to it as quick as possible. But of course, always you will get as well references and bibliography. So that's the base, right? So the bibliography database is the base, but on top of this, all the data and information. That's why I call Reaxys a factographic database, not a bibliographic database. The interface we will see today, but we will not do today's quick searches. We will not do, well, we do the structure searches, but as a part of a query builder. So query builder is, according to the statistics, used by 5-7% of people, or maybe in other words, 5 to 7% of searches on average are done using query builder. Most are done using quick search and structure editor. So I hope that after this webinar, you will see how great tool it is, and your query builder will also become your favorite tool, as is my favorite tool. What else? Yeah, retrieving options, but that's when you do the quick search, we will use the query builder. So we will decide which type of fields, which type of questions to ask. Just to add on extracted information, just wanted to show you how much it contains. And this was already covered in my previous trainings as well. A lot of extracted information, and what is important, it's experimental. Experimental, which is reported in papers, in patents, as compared to other databases, which give you a lot of calculated data, which is fine. Calculated data, standard conditions, this is also maybe quite important, but we believe for discovery purposes, but also for education purposes, the experimental data is much more valuable. So just to finish this introduction, Reaxys is, as I said, a database which I call a factographic life science database. It contains a bibliographic part, over, I think it's 120 million records now from 18,000 journals. It contains substance database, close to 300 million substances, including all the integrated resources like PubChem, like commercial substances, Reaxys targets and bioactivities. So all these substances are in property database. This is a strong, I think, point here, because, as I said, experimental, extracted from literature properties, physicochemical properties, the huge database. And this is very important. And they are distributed in 500 fields. We will see this today. We will focus on in Query Builder on using these fields for our searches. We will see how it goes. Then to finish this off, chemical reaction database, close to 70 million reactions, including reaction conditions, experimental procedures, everything. Then bioactivity database and pattern database and predictive retrosynthesis database. This is all Reaxys. So I think quick introduction. If you want to know more, let me know. This is really quick. We don't have enough time to go through all of this today. What we want to do is we want to the live database and start searching. And as I said, I know most of the searches are done in quick search, which is the default option. But today we go to Query Builder. Before I go there, one more remark. I always talk about this. Please try to log in. You see I'm logged in here on the right side. You can use as anonymous user, but this is not giving you all the benefits. First of all, when you work as an anonymous user, your session might stop after 30 minutes. So you will be you will need to restart Reaxys. And when you are logged in, the session lasts much longer. You also can save your searches, set up email alerts, personalized interface, many different things. It's easy, free, costs nothing, and it gives you so many benefits. So I always say, please log in, and you will see it's much better. And you can make computer remember your password, so you don't need to basically do anything. When I just open Reaxys, I'm already logged in. So very easy. So today we don't do quick search, as I said, we do Query Builder. So let's go there immediately and let's see how this works. So Query Builder works in this way that we have this working area in the middle, and on the right side we have fields. And you see these fields are grouped into topics and keywords, identification data, physical or physicochemical properties, spectra, target and bioactivity, all the other information, reactions, and bibliography. So you see all the main groups are covered. And how to use this? Maybe let's start with one field. Maybe let's go into physical properties. So I click on physical properties and I click on first one on the top just for demonstration purposes, which is melting point. So when I clicked on melting point, you see this is automatically added to my interface. I can immediately use it. I can open fields. And of course, every field will have different sub-fields related to what it is, right? Here I have melting point, but also solvent. So how about searching for compounds that have a melting point? You can do greater than, lower than. I will just leave equals, and I will say compounds that melt somewhere between 520 and 530 degrees. You can do ranges as well, right? Very simple, very generic search, of course. And here I need to define what I'm searching for: reactions, targets, substances, documents. In this case, I'm searching for substances. So very simple, very generic, you might say, but still quite interesting search. So 666 substances have melting point in the range I asked for. So always when you search, then you look for something called heat data. Heat data is the answer to your question. Click on melting point and you see 520, that's the range, right? And you always see the original source of this information. It can be article, it can be a patent as well. And for each of them, you will have the same, right? And this is all experimentally measured. And you see, you will have all this information. We have all different compounds. Now what we could do, we could say, okay, we have a melting point, but how about some group of compounds? This could be a structure. This could be a specific compound, could be substructure, could be also molecular formula, right? And I can use molecular formula as well. And you notice when I clicked on molecular formula, the second field is added and automatically it's connected with operator, logical Boolean operator, and which I can change to or, not, near, next, proximity, and so on. We will try to do this later. So how about compounds, for example? Let's go for boron compounds, okay? I'm in boron chemistry, so I'm looking for boron compounds. So if I would leave is here, that means that I would be looking just for pure boron, and this is not what I want. I want boron compounds, so I want the molecular formula to contain boron. So I will change is to contains. Easy, isn't it? So just for the purpose of this search, it's very, very easy. I just say contains B, boron, and I click on substances. So I leave my first condition, the melting point, and I also want to do this not for all 666 compounds, but just for boron compounds to see if boron compounds are in this group. Okay, so I see there are 3 compounds in this group, potassium tetrafluoroborate, for example, one of them, and melting point is 530. Like this, just on the edge of my search criteria, cesium tetrafluoroborate as well, and also other compounds like this one. And for all of them, we will have a melting point within my range, 520 to 530. So you see how easy it was. And for each of those compounds, then I can explore their properties. I can go to documents. I can go to preparations. I can go and go in and see if I can order this. I can go to my commercial substances. I can go to creation of synthesis plan. We've done this in the previous webinar. So I can do a lot of things here. Or if I want to study it more, I can also click on 3 dots and, for example, copy structure to query or copy smiles if I want to copy this to another structure editor. So many things you can do from here. Very, very easy. So this was like a simple search, and you now already know we can have one field, you can have 2 or more fields, and they will be connected with the logical operator, right? So very, very easy, and you can build this as much as you want. I will delete all. How about the structures? Can we search for structures and combine it with something? Okay, another quite easy but very practical search. We are looking for phenylpyrazole pesticides, okay? We're looking for compounds that have a phenylpyrazole structure in it, and they are pesticides. How about that? So we can also use structure as our search. You see, I ended structure, and structure can be a field. This is what we call field. So let's go for phenylpyrazole substructure. So let's draw this quickly. And okay, nitrogen, hello, okay, nitrogen. And we want double bonds here. And I'm just saying substructure, okay? So there was a part on structure editor, our first webinar. Watch it if you want to go more details on structure editor. Here we just search for a very simple substructure, okay? We don't want to be specific where we substitute. We just say substructure, meaning we are allowing any substitution on any atom. Just first we want to see all the compound space and see how many are there. I'm also going for stereo, salts, mixtures. Okay, I will not switch it off. I will just leave it for a purpose of time. So transfer to query. And this is the first part of my question. You see, I will be translating my research question into the query. My first part of the question was, I want the phenylpyrazole structures. So this is a substructure search on all atoms, right? And the second part of my question is, I want to see pesticides. So then I have to figure out which field do I want to use. And I told you there are over 500 of those fields. And you see, when I open those, it's a lot of different fields, bibliography on reactions and so on. In most, probably I will go to the fields in the group of other, and you see the nice field called use. I think this is the field that makes more sense. So definitely there is a challenge that you need to figure out. You have to think which field you want to search. But I think when you define your research question, then you know, basically you know what you are expecting, right? You want the substances which are used as pesticides. So let's use the field called use. So I click on use and it's added. And as usual, operator and is added, which is fine in this case. Show fields. And you see, I can go for laboratory use or use pattern. In this case, I think use pattern is more a practical side. Laboratory use is more how it is used in laboratory. So use pattern, and we want to find pesticide, right? So pesticide. but you see, it could be pesticide, pesticides, pesticidadial even, okay. But let's stay with this. The only thing we might do is we might say, change this operator is to starts with. Starts with means we are saying the word should start with pesticide and then could be pesticides as well. Actually, you could do the same by leaving is and putting the question mark here. Question mark replaces one letter or no letter, right? We know Boolean operator, and I think these days it's not used so widely because I think Google now, which is spoiling us, is basically searching for everything. But in all times but even Google has the advanced search option where you can use the wildcards and question mark in this case would replace one letter or no letter, and the asterisk would, if you would put asterisk here, it would mean it can be any number of letters, okay? But let's start with this. And it's equal to changing the operator to starts with. It's exactly the same. So let's look for compounds with this structure which have a specific use, okay? Let's see if this works. All right, so we are looking at 32 substances. First one on the list is fipronil, which is a well-known pesticide. So no wonder. And you see our heat data again, which is the answer to a question, and use is the answer. We click on use and we see preparation of pesticides, for example, and we see this is a Bayer patents. We also see some more or less known compounds, but sometimes you will also see some compounds that maybe are not obvious pesticides, and pesticidal mixture combination with chemical pesticides and so on, and biological pesticides. So you see, you get a lot of information which is extracted, and you see for a patent, you even see where it is in a patent, because patents, you see, this is already minimum 220 pages because this is the page to 17 to 18 and to 19. So it must be quite a long patent. And then you can go to full text, you can see the details and so on, but at least you know what it is. And you will notice also that your scaffolding that you were searching for is in blue. So you see where is your phenylpirazole scaffolding, and then you see the rest of this. And then you can go and analyze the substances. So this was searching for pesticides, and we can be even more creative because we could even say, and how about all other like biocides, fungicides, biocides, fungicides, and others, and could we search for this in one search? So basically, how could we ask the question, can we search for all the sites? The compounds or the use that is ending with site. So how about leaving the site here and saying we want to all words that end with site, okay? So pesticide, biocide, fungicide will all be okay. And let's see if this could work. And the substance is the same, or the substructure. So let's have a look now what we will get. And fipronil is still there, but I just want to open this and show you that now we are getting that it actually is insecticide, it's pesticide, it's biocide, it's fungicide. So being a little bit more careful and intelligent with how we ask the question, we are getting much more information, which is fantastic because you don't need to search many times and you don't need to search separately for all of these. You can, if you build your question properly, you can do it in one search. So this was searching for structures. Of course, you want to know how to search for reactions. Okay, so then we need structure editor again. And I prepared the reaction of, to make it a little bit more complex, I want to look at compounds with 3 to 6 membered heteroring with 2 to 5 atom chain attached to it. And then I want to see the reactions in acetonitrile, okay, as a solvent. Oh, okay, that's quite a big question, and let's maybe do it one by one and start drawing this. So first of all, I said I want to have 3 to 6 atoms of a hetero ring. So 3 to 6. So I think we will start with 3. And we say, how can we make it up to 6? Okay, and this is something I covered in my structure editor webinar. We can also repeat atoms, but we also want the chain as well. Oops, sorry, that's not what I wanted. I want a chain here. So what I will do is I will use the repeating unit option. And here I said I want to have a chain 2 to 5 atoms of carbon. So with one search, I will do from 2 to 5 carbon atoms chain. And also I can repeat atoms in a ring. So because I have now 3, I can repeat one of those carbons and say, I can have 1, 2, if I need a 6, I need 4, right? If it will be 4, if it will be 4 instead of 1, plus these 2, it will be 6, correct? And I wanted the hetero with a nitrogen, so I will need a nitrogen here. Okay, it becomes a little bit more complicated now. And I want the reactions. So this is my starting material. Okay, this is an example I was showing in my structure editor training as well. And I want the solvents. They should be with potassium carbonate as a reagent in acetonitrile as a solvent. And the thing is that what I was also talking about at the structure editor training, we can put the reagent or a catalyst above the arrow, but we cannot do this with the solvent, right? So let's first put the reagent. So I will use the option called insert structure from name. Potassium carbonate, this will be my reagent. And make sure you don't put it like this, that it doesn't overlap with your starting material, because then it doesn't work. I put it here. So this is my reagent. So this is possible, but how can I do the solvent? Okay, so to do the solvent, I will need to use the power of a query builder. So I think that's all I could do here. So I have my ring, which is from 3 to 6 atoms, right? Because this is a repeating unit here on this carbon. And I have a chain from 2 to 5 atoms, and I have my reagent. Quite a lot is going on here, but that's fine. So this is the first part of my question. The second part of my question is I want the solvent, which is acetonitrile. How can I do this? I will need to use the additional field called solvent. And this will be somewhere in, most probably in reactions. Now, I think it's the time to introduce you to one more information, one more tip. You don't need to scroll through all these fields. You can search for a field. So I will search for a field called solvent. So you search for what you want to search. This is a little bit crazy, but I think you can get this. You search for the feature, the type of information you want to search. If you want to search for density, then you search for density, right? And I want to search for solvent. So I just start typing, and normally 4 or 5 letters is enough. And you see I'm getting a lot of fields related to something with solvent. In this case, the field I want to use is this one, solvent reaction details. And here I can put now my solvent, which is acetonyl. And you see Reaxys is helping me and finding in a dictionary in Reaxys 3 also my solvent. So now I have a quite complex structure because I have a repeating unit on the chain and on the ring. I have my reagent and I have my solvent. So you see, using Query Builder, I can do really a lot. And be careful now, we don't search for substances. Now we said we want reactions, right? So we are searching for reactions. And let's see what we are getting. 23 reactions. Let's see if this makes sense. Okay, so my structure is here. So it is a 6-membered ring. It's hetero with nitrogen, and it is the ethyl, also ethyl part with it. So it is in acetylnitrile, and it is with potassium carbonate. Beautiful, right? So now I have the whole group of compounds which fulfill my criteria, and you will see these are all 6-membered, but I have also 5-membered. I have a different chain or different length of the chain. Here it's a butyl one. It's 4, and it's 5-membered ring. I will find also 4 and 3-membered rings as well if I scroll down. But of course, 5 and 6 member rings in this case will be the most popular. So you see with one search, I was able to do different substructures, but also not only reagent, which I can do always, even in a quick search, because I can put this above the arrow. I was able to search for the solvent as well, which you cannot do in a structure editor. Okay, so solvent is a nice option here because you can search for it here. Okay, I hope it's okay. If you have any questions again, please ask. I see no questions, nothing in the chat. Great. We go on. We don't have so much time. So delete all. We clear this. How about searching for natural products? Okay, natural products, that means products isolated from some natural thing. And there is also a field related to this in other group, isolated from natural source, or you can search for this field like natural, for example, and you see 5 letters is normally enough. And I have isolated from natural source, show fields, and I can now say from what natural source. Natural source can be a plant, tissue, mineral, result of a natural process like fermentation, basically anything that you can get from nature. How about searching for compounds isolated from garlic? Okay. So I could do it like this, and I could click on substances and see how many are isolated from garlic. But I can also be more, and I think the power of Query Builder is that you can do more than one field. And I also want compounds. I want to look at disulfides, for example. This is also the example I was giving in a structure editor search. So we use the structure very quickly. Disulfides have a sulfur-sulfur bridge. So I will use the sulfur-sulfur. This is just basically sulfur-sulfur bond. This is what I want. And I will do substructure again. Very simple. I don't want to go for very exact structures. This time I want to see if there are any disulfides isolated from garlic. And this is quite enough. Substructure, very simple. So now my question has 2 parts. Compounds isolated from garlic that has sulfur-sulfur bridge. I'm looking for disulfides mostly. And in this case, I'm also searching for structures, and I see 47 substances. I see my sulfur-sulfur bridge is here, like the allyl sulfide, and heat data isolated from natural source. Garlic is there. And here is your literature. You can go and check. You can go to full text. You can go to details. Maybe you can go to abstract, whichever you like to see. All the information is here. Okay, how about if we go into the area of catalysis, for example? So we want to find Aryan palladium-based catalysts, for example, used in stereoselective catalysis. Again, quite a big subject, isn't it? So we say Aryan palladium catalyst. How to search for it? Structure editor will not be very helpful. In this case, I would use molecular formula. And I would say Aryan. I could say Aryan palladium contains, but now let's be a little bit more specific. And let's use the wildcards as well. You remember I was talking about question mark replacing one letter, asterisk replacing many letters. Here, question mark will mean any number of atoms of Aryan in this case. Palladium, the same. Okay. And I could leave it like this, or I could also go for like any other atoms, which is the asterisk in this case. So there is a little bit different meaning in the molecular formula. Question mark says any number of atoms, and asterisk means any other atoms. So we are looking for all compounds containing any number of atoms of Aryan and palladium, and we also want to see if there are any other atoms groups connected to it. So this will be all Aryan palladium compounds. We can even go and check. You don't need to build everything on the spot. And you see there is 6.7 thousand compounds. And nice. But then we go back to Query Builder and we say we wanted to see those that are used in stereoselective catalysis. So there will be something with catalysis. Okay. I'm looking for a field cataly, and I think the one that will be good, will be relevant, is catalyst investigation. And I open the fields, And now I think it will be specification. I mean, not always you know what is in these fields, and sometimes I also don't know. Now the next tip is each field will have this small mark, which is the link to a dictionary. So I can go and click on it and see investigated catalysis, for example, investigated characteristics like catalyst regeneration, like activity, surface area. That's not what I wanted. Specification, I think it will be specification. And indeed, here I have like regioselective, stereoselective, and stereoselective is what I wanted, and I transfer. So this is here, right? I could also go for classification, like homo and heterogeneous. I could go for type of reaction, like oxidation, reduction, acetylization, whatever, and also co-catalyst as well. But I think this is now okay. I wanted stereoselective catalysis and Aryan palladium compounds. So let's see what happens now. Okay, out of these almost 7,000 of compounds, 38 are reported to be used in stereoselective catalysis. So I have Aryan, I have palladium, and I have heat data catalyst investigation. And indeed, it says stereoselective catalysis. So you see how easy it was. Now you can go through the list. You can maybe export all the compounds to any format if you work with ELN, or you want to export it to SD-MOL file, or just smiles to have a look at this, whichever you want. And you can also decide what data you export. So it's quite easy. So the first thing is to find the content, and then you see, and then to analyze. This is the second step. So quite easy. So if you're in catalysis, you want to search for specific compounds, you can use structure editor if you want, or you can use molecular formula for this. Okay, I see no questions. Then we go on because time is running and I still have many examples. Biochemistry, very important, right? Biochemistry. So we want to look for compounds that have certain structure. Maybe let's look at flavon and pyrrolidine, sort of type of substructures, and we want to look at those that have antineoplastic effect, and we want the compounds that have maximum free rotatable bonds, okay? Because we know less rotatable bonds, the better, the more potential drug it is. So how do we start again? I think again we start with the structure this time, and we said we want flavon and pyrrolidine. I also want to show you one thing that I think I didn't show in the structure editor. So first of all, we use insert structure from name, right? So I don't want to lose time on drawing. So we have flavon and we have pyrrolidine is actually quite easy. Okay, we can do this like this. Now what we want to do is we want to search for substructures, of course, but there is also more options, and more options is keep fragments together. And by default now it's done separate and together, so it will be together, or you can decide that it is only together, right? So you can sort of show the building blocks and ask Reaxys to bring you all the compounds that contain these two building blocks. So we transfer to query, and we want to look at compounds that have antineoplastic effect. So we talk effect, right? Effect, substance effect, and this is added here below, and we say antineoplastic. Okay, I see it exists, and I think I will go for is, not contains, because it's just antineoplastic. And we also wanted maximum free rotatable bonds, so that's a part of a drug likeness. Let's see. Drug likeness. And so we're adding the third question now. Show fields again. And you see you can enter a lot of information. I have rotatable bonds, so I want to have less or equal, actually, free. Okay, maximum free rotatable bonds. So I don't want this compound to be really too flexible. And I'm ready to ask the question. Let's see if this works. Now it's quite a big question, so it might take a little bit longer. No, it was quick. So I get 56 compounds. 1, 2, 3, okay. And now I go to two places. First of all, I said look for heat data. Heat data for bioactivity is never below. It's somewhere here. So that's maybe a little bit misleading, but look for heat data. So first of all, I'm looking for bioactivity, and I see there is a lot of in vitro information. And I remember I was talking about extracted information. There is a lot of extracted data. I see it's a cytotoxic agent, so it's basically the same as antineoplastic. So it's sort of a synonym search, and I see all the data. I see the cell lines, I see the effect, and I see the original information of this data as well. What I also want to look at, I want to look at drug likeness, and you see, I see C log P and so on. This is calculated data, and I see the rotatable bonds are actually free into PSA and so on. So I see all the data in one place for all these compounds. So that's very, very easy now to look for this. So this was quite a complex question, and I think we got a very nice set of 56 compounds for these substructures and for these type of data. Okay, I see no questions again, so we go on. How about material science? I'm trying to go into different areas of chemistry so that you see that Reaxys is not just organic chemistry. It can answer a lot of different questions. So now I will change from bioactivity to material science. Now I was also asked about semiconductors that are metalloids-based semiconductors, okay? So metalloids-based semiconductors. Semiconductors will be most probably the use. So this I know, but how to do all the metalloids? I think we will use molecular formula again. But this time we will not use this lookup or the dictionary. You see, it also has a link to periodic table. So this is really nice because I go to periodic table, and of course I can go for single atoms. But even better, what I can do, I can go down and I can look for metalloids. Metalloids are here. So you can go like halogens, noble gases, alkali earth metals, so whatever you want. I want metalloids. I'm using metalloids, and you see automatically molecular formula is filled in for me, like boron, silica, germanium, and so on. Now what I need to do, I want any number of atoms of those, so I will put a question mark after this. I'm saying I want any number of atoms of any of those metalloids, and I want any other elements and other groups. So I'm just putting the question mark for any number of atoms of those, and I'm putting asterisk, meaning I want any other atoms as well. And I say use this formula. So you see how nice it is. It's a very nice formula and have all compounds based on all metalloids. I can edit it if I want to get rid of one of them or add maybe something outside of metalloids as well, no problem. So you can use them in here in the brackets. Now I said I want semiconductors. I could use the field called use, but even better, my suggestion is look at those fields in the first group, topics and keywords. There is a field called substance properties and comments. It tries to look in different fields related to a substance. There is also a similar one for reactions. And I want the semiconductor, or maybe if it will say semiconductive, so maybe actually it would be safer to stop even on D, because semiconducting, yeah, it can be A or U, or even double D with the error. Okay, nice. So I would say starts with semicond. So any word starting with this is okay then. And we look for substances. Isn't this beautiful? 32 substances. They will all contain at least one metalloid, of course, and the use is a semiconductor. Beautiful. And you can go for pure forms, like pure elements. You can go for compounds, boron, silica, cadmium, and so on. And you can go through the list. Very, very easy. So you see the power of of this. How about spectroscopy? Okay, we look at compounds. Let's maybe do some structure again. I'll just use benzene sulfonamide substituted on carbon 4. Benzene sulfonamide, again, very simple. Instead of using the substructure, I will try to find compounds substituted on fourth carbon. So I will do generic group. Okay, this was all in a structure editor training. If you want, you can look at it. I just want one substitution, so I don't search for substructure. I search for one substitution. This will be my group of compounds. And I want to find 19F NMR data. So NMR, this will be my field I'm looking for. NMR spectroscopy, adding this. And I want nucleus. I want this to be 19F. And this should be enough, basically. And I go for substances. Okay, 608. So this is still quite a big group of compounds. You see my structure. This is substituted on fourth carbon. And I see NMR data. And all the information is here as well. And there is even more information because it also gives me information what is the location in a pattern specific. Wait, is there a question? Can you provide an example of reversible chemistry with respect to polymers? Polymers. Okay. Polymers are a little bit tricky. This was, I think, my next example. Polymers. Reversible might be a tricky one, but let's start with polymers as such, okay? Yeah, polymers is, it's not an easy thing to do because polymers are not substances that we can map, because every structure that we map means that every atom and every bond is mapped. And then if you go there, you can go and see the properties of, if you right click, of every atom and every bond as well, right? Oops, sorry. And bond properties as well. And you can see what it is. In polymers, they are not finite in terms of molecular mass. So we can do this for monomer, for oligomer, but for polymers, it's sometimes difficult. But we can try to search for reactions. And then let's see if this is helping us. Okay, we delete this. Okay, we will need a structure editor anyway. And let's do something simple again, like acrylamide maybe. Okay, acrylamide, and basically that's our starting material. And that's a reaction as drawn, that's fine. And now what I would do, I would use the field called reaction data and conditions, the other of these generic fields. And I would try to find something that contains polymerization, contains polymer. I think that would be enough. Polymerization, and polymerize, and so on. And look for reactions. So you can do this, and then what you are getting is the product is not something that is exactly mapped, but you only get the name of polymer, right? And then you can have to dive into maybe content, you have to dive into experimental procedure. Maybe we should use reversible if we want it as well. With this, we could try to find those that contain these keywords, but most of the polymer search is based on keywords, not on the structures. So I think I would use the reversible and polymer and try to build something like this, but it is absolutely possible. And you see, we can search for polymers as well. I hope okay, thank you. Please, yeah, you can always contact me and we can try other examples. But I still have so many other things I want to show you guys, so that let's skip this for now and let's go on, and contact me if you want more. Check it for yourself and we can look at reversible as well. How to do this? Okay, physical chemistry. Okay, I'm trying really to cover all different areas. How about absorption? Absorption, is there such a field? Absorption. Let's see. Oh, okay. There is such a field. Okay. And again, I have fields. I can fill in everything. In this case, partner. This is, I think, the base information you need to know. Partner is a solvent. So how about looking at absorption at specific sorbent, like, for example, zeolite, okay? ZSM, for example, 5 zeolite. Zeolite. I think I would use this one. Funny because it's zeolite or zeolite with E. Okay, let's do the question mark, and then we have both. So I'm looking at ZSM5 zeolite, and what can we absorb on it? I don't know, gas, carbon dioxide. So how to do the carbon dioxide? Drawing doesn't make sense. Molecular formula, better, right? So we just say CO2. In this case, we just say exactly because it's very simple. And we look at substances because basically what this will do, it will search for carbon dioxide record, nothing more. But not the record is what is interesting. What is interesting is heat data and absorption, because we have 22 out of 20,000 hits, and you see we have absorption and disotherm, absorption and desorption isotherms, for example, on ZSM5 zeolite, and we see two articles immediately. If you wanted to go all zeolites, maybe this was too exact. How about just saying any zeolite? This will be many results. So again, one substance, we get the carbon dioxide record, and we see 20,500 records, which should be there as well. So you see, why not all? That's crazy. Oh, okay. The weakest chain, of course, is a human. What did I do wrong? Anybody knows? I did is. Sorry, not here, is. Right? What I should do is contains, so that if there is like ZSM5, ZSM4, zeolite, I should allow this. So that's why I should say contains. I was thinking why I'm not getting the results. Sometimes if you don't get the results, think what happens and see what's going on and look at this. And we have all different types of zeolites. Okay, and there is much more. So physical chemistry. Okay, we have only 7 minutes to go, and I still have many things to show. I go back to Query Builder. Okay, how about text searches? Is Query Builder good for text searches? Of course it is. And there is another field here, which is title, abstract, and keywords. It's actually also here on the top, so that because it's quite often used. And we can use this. And by the way, we can use the same field many times as well. So how about fluorescence sensors based on synthetic nanomaterials? Oh my God, again. So we look for fluorescence sensors, which are based on synthetic nanomaterials. So, okay, fluorescent sensors. So we do this question mark, which is replacing S or no letter. What I would also do, I would put this into quotation mark, because I see Reaxys is not helping me with this. That means that this might be not a concept which is in the dictionary, so I force it by just putting the, I don't want fluorescent and sensor somewhere into different places of the article. I want them to be together. And then we look at nanomaterial. Oh, this already shows up. And I also want something about synthesis of this. So I say synthesis. I could also use preparation. So I can use another tip, semicolon. But semicolon in this case basically means or. Okay, so I can like put many different fields in one, many values in one field. Use the semicolon, which means or. Good. Let's see if this works now. Be careful. We don't search for substances. We search for documents. Wow. Okay. 198 document preparation, method application, carbon material, fluorescent sensors. Okay. Nice. But can we do it even better? How about regrouping a little bit? So First of all, I want synthesis preparation of nanomaterials. So I want synthesis or preparation to be before, just maybe up to 5 words before the word nanomaterial. So I can regroup it. So what I will do, I will take this field to the end. Okay, nanomaterial put to the end. You can just drag and drop these fields. It's really easy. It's a graphical interface. And I want this to be after synthesis or preparation. So I will change and to next. Okay, I could go for near, but near doesn't show the order, but I want the order. So I go for next. If I do next, I can select how many words apart they have to be in. I'm quite generous. Let's use 5. So not more than 5 words after synthesis or preparation, I have to find the word nanomaterial. What I will do also, I will make a group of these two fields. So I will take the last field and put it over, drag it over this one. You see? So I first want Reaxys to run. It's like parentheses in mathematics. I want it first to run this type of search and then combine it with and with fluorescent sensor. Makes sense, no? Let's see now. There was 198 documents. Now I'm getting 7. And most probably these 7 make more sense. Most probably they make more sense, but it's up to you to judge. Okay. I was going to show you much more, but I don't have time. I also wanted to show you that you can edit things, and this is quite important. I'm looking for thermal conductivity of a metal or alloy. I wouldn't do it there. I would just start here in a quick search. And instead of going into 5,000 substances that contain data on thermal conductivity, you can use this edit in Query Builder. It's a very useful feature. If you do the quick search, sometimes you do edit in Query Builder. It asks me if I want to replace the form, it means to delete everything that I was doing before in Query Builder. I say yes. And look what Reaxys is doing. It actually finds the fields and it tells me how it's looking. So sometimes if you want to see how Reaxys thinks, go to edit in Query Builder. And it says transport data, thermal conductivity, but also, or transport phenomena, thermal conductivity. And now you can maybe use molecular formula, say I want all the Aryan nickel alloys and go for substances. Oops, no results. Maybe I did something. There is no. Okay, let's do other. Sometimes you get no results. Why not? Then you have to think why. Okay, now it's better. And I'm getting some alloys with a nice data on thermal conductivity. So sometimes you have to go quick search, edit in Query Builder also. I also want to show you, I have 2 more minutes, really, and I think we have no time for questions, but you can always ask me the question via email. What I also wanted to show, no, not Query Builder, sorry. I also wanted to show you 2 more things. First of all, you have fields. We were using fields all the time, but you also have forms. No forms found. Oh, I think there is a bug. Oh, okay, here they are. First of all, you can save your own forms if you want. So if you draw something, just click on save and save form. Make sure you do whatever, then you just do the save form and make sure you also include current value so that you include the drawings, the structures, the data. You just give it a name and you save it. And then you will find it into your forms. But you have to be logged in, remember. There are also Reaxys forms. Let's keep this. Like bibliography, physical data. If you don't know for bibliography which fields to use, this is a nice combination of fields. So you have different fields you can go and choose, right? Very easy. But even more interesting are Reaxys targets and by activity forms because they are not only the collection of fields, but they are also pre-fields. So now it's up to you to add maybe a part of the structure. You edit this, but there is a lot of information already done. Selectivity profile, beautiful. Just enter both values. Maybe let's do it quickly. And maybe I will drag over a little bit over 1 hour. Why not? And measurement px, which is measured by activity. We don't have time now to talk about this, but basically it's 1 to 14. It's a negative logarithm. We do a high like 8, and we compare this to Cox 1. This was 2. wrong. This should be 2. I want high activity on COX-2, low activity less than, I don't know, 5. Okay. I just have to show it to you. This is so fantastic. And use forms. These are not only fields, but also forms. And you get all the data. And then you go into bioactivity visualization. And you get, and this is a separate subject we can talk about, which is the bioactivity visualization. And how do you clean this data? How do you export it? It's beautiful again. The last thing I wanted to tell you, okay, we don't have time for this. Okay, maybe the last example really, because we were using and or all the time, and sometimes it's very useful to use not, for example, like if you want to deduct searches from each other, which you can also do. I want to search for Marcus structures of, let's use again something very simple, like a flavone. I'm looking for like flavonoids, right? Substructure. And here I will mark related Marcus, okay? I'm searching for everything, including Marcus structures. So this was my first search. Now I can do exactly the same search, the second one below, you see. I'm doing exactly the same. Okay, and again, substructure, but this time I don't mark related Marcus structures. That's the only difference. And now I'm changing end to, you guessed it, to not. That means this set of results with Marcus structures minus this one that doesn't have the Marcus structures. What will be the result? Only those that have Marcus structures. Let's see if this works. 355 substances, and they're all Marcus. How beautiful it is. Nice, very nice, beautiful. So that would be the way, right? So think about this. Not always it's and, sometimes it's or, sometimes it's next, but sometimes it's also not. Whew. Okay, I think I'm 2 minutes past the time, but I hope it was worth it. Maybe last 2 minutes for any question if you have it. Nothing, really. Okay. I know it was a lot. You have to digest it. And once you digest it, please let me know if it works. I will send you the email today later anyway with the link to recording. And yeah, if you want to get certificates, so you'll have my contact and you can always contact me. Thank you so much. And yeah, thanks and for your participation. And yeah, let's be in touch and have a beautiful day. Bye bye. Thank you. I'm closing the meeting. Maybe I should stop the recording.